Hey guys, this is chapter 4, section 5, naming acids. So what we're going to be talking about in this one is we're going to learn how the anion composition determines the acid's name. So specifically, we're going to be talking about whether or not it has oxygen in it and how that is going to affect its name. And then we're also going to learn how to name them. And there's going to be a couple of rules that is going to determine that. Now, a couple things you probably want to grab or know before you continue watching the video. I would make sure that you know your polyatomic ions that you needed to memorize. So from that chart on page 100, make sure that you know those. And then also, if you don't know them, I would make sure that you have that as a reference sheet just to get you through this video. Okay? So the first thing we need to talk about when it comes to naming acids is how we determine when we're looking at an acid. So when certain molecules are dissolved in water, they can produce H plus ions. Now, if you think about when we break down water, when something dissolves in water and we break it down, or we break down that molecule, what you can get is H plus or OH minus, because water is made up of H2O, and so when it breaks down certain ways, we can get H plus or OH minus. The OH minus, if we got that, we would end up with a base. But we're not looking at bases right now, so when we get an H plus, that's going to give us an acid. Now, it says protons here because when we're talking about H plus, H is on the periodic table. It's on the top left-hand corner, and its atomic number is 1. If its atomic number is 1, it has 1 proton and 1 electron. When we make it in an ion and it becomes H plus, all it is just a plain proton because that electron goes away. So when we're adding this proton or H plus ion to other things, it makes it acidic. And it was originally first found that things were considered acidic when they had a sour taste. And that's due to this H plus ion. Okay, so an acid can be viewed as a molecule with one or more H plus ions attached to an anion. So this H2SO4, SO4 is your polyatomic, and it's attached to 2 H plus ions. Okay, and how we name this is going to depend on whether or not there are oxygen present in the anion, and that's what that last bullet is saying. Okay, so when we are looking for acids, we need to look and see whether this H plus is acting as the cation. If it is, it's going to be an acid, and we need to name it like an acid. Okay, so to name it, here's our first rule. So if an anion does not, so let's look specifically, does not contain an oxygen atom, the acid is named, that should be a D, is named with the prefix hydro and the suffix ic attached to the root name of the element. So we're adding hydro at the beginning, ic at the end, and then we actually add the word acid after that. Okay, so let's look at some examples. So HCl, right now we would name it as hydrogen chloride, right? Take the first name, take the second name, add IDE, type 1, right? When it's dissolved in water, and we talked about this on when we determined what an acid was, when it's dissolved in water, we add hydro at the beginning, chlor is our root word, ic at the end, so we get hydrochloric, and then we add the end word acid at the end. So hydrochloric acid is HCl when it's been dissolved in water. Okay, so when H, and then so hydrogen, and then we have cyanide here, is dissolved in water, we have hydro at the beginning, cyan as the root word, and we change the ending to ic, so hydrocyanic acid, and again add that end word there, will be how we name it. Okay, again, because it does not have an oxygen present here. Okay, so when we have H2S, so hydrogen sulfide, when it's dissolved in water, again, we're going to take that hydro prefix, keep the root name, so sulfur, and then instead of sulfide, we're changing the ending to ic this time. So hydrosulfuric acid is going to be the name. Okay, so biggest thing here, just think, does the anion have an oxygen? If the answer is no, you're just adding hydro to the beginning of the root word, ic at the end, and then adding acid as the second word. Okay, so not too bad. All right, let's move on to rule 2. Okay, so rule 2 is going to be when the anion does contain oxygen. Usually, when it contains oxygen, it's going to contain a polyatomic ion that we talked about in the last lessons. Again, you want to make sure that you can recognize these because it's going to be important for being able to name the acids, because that's going to be the root name most likely. So the acid named is formed from the root name of your polyatomic or base word with the suffix ic or ous. Ic is similar to rule 1, but it's going to be a little bit different here when you need to determine whether we're using ic or ous. So when the anion name ends in ate, so like phosphate, okay, it will change to ic. When an anion when it ends in ite, so it could be nitrite, it will change to ous. One way I remember this is that I ate ick, or like ate something icky, and then ite us, I think of like bronchitis, itis. Those kind of go together. So ate ick, ite us is how they're going to switch. Okay, so let's look at an example here. So we have H2SO4. Again, we have this positively charged hydrogen, and then sulfate is going to have a -2 charge, and that's why we have 2 of the oxygens. It's still a balanced formula. So we're going to look at, there's no hydro in this name anymore, but we're going to look at the ending of that anion. And because this one is 8, the name of the acid is going to contain ic at the end. So we're going to take sulfuric acid is going to be the name. Okay, so this one, it's kind of blocked here for you. I don't think I can move that, but it would be H2SO3, and it's a sulfite anion. So again, the important thing here is that we look at the ITE, and because it has the ite, it's going to change to OUS in the acid name. So it's going to be sulfurous acid. Okay, so the biggest thing when it contains an oxygen is changing ate or ite to ic or us. Okay. All right, so those are the only two rules. All of the naming of acids will fall into those categories. So on the next slides, we're going to start to practice those. Oops, I lied. It's not the next slide. It's the one after this. So this one is just kind of a review flow chart to help you determine which way you're going to name your acid. So the first thing you need to be asking yourself is, does the anion contain an oxygen? If it's a no, it's going to fall under that first rule, and we're just going to add hydro to the anion root name and ic to the end of it. Okay, so hydro, root name, ic, and then the word acid. Now, if the anion does contain oxygen, we need to go through another checkpoint. So we need to check the ending of that anion. So if the anion contains oxygen, we need to look at the ending of it. If it is ite, we need to change the ending to us, OUS. So we're just going to take the root name and then add OUS, and then add the word acid, as we see down here. And then if it is ate, we're going to add the ic suffix to the ending, and then the word acid. So I have the root word ic and then acid. No hydro if it contains an oxygen atom. Okay? Okay, now seriously, on the next slide, we're going to do some practice. So here we go. So H and F. First question we need to be asking ourselves, does it contain oxygen? Our answer is no, so we automatically know that we're going to add hydro, base word, ick, and then the word acid. So we're going to have hydrofluoric acid as our name. Okay, so pretty simple. Just two main parts, hydro, ick, base word, and the name acid. Okay, so HNO3, so this one does contain an oxygen, so we need to look at the polyatomic ion's name. So what does NO3 stand for? NO3 stands for nitrate. And because it has this 8 at the ending, our new ending is going to be what? Ick. So our correct name for our acid will be nitric acid. Okay. Let's try it again. So HNO2, again, does the anion contain an oxygen? Yes. So we can't do the first way. We're going to have to do it the second way. So we need to know what NO2 stands for. NO2 stands for what? Nitrite. Because it stands for nitrite, we're looking at this ending ITE, which needs to be changed to OUS. So our correct name for our acid will be nitrous acid. Okay? If you have any questions about those, make sure that you let me know. Okay, one more set of examples here. So when we have H3PO4, again, does the anion contain an oxygen? Yes, it does. So we need to look at the polyatomic's name. Now, what does PO4 stand for? Should have it memorized as phosphate. Okay, and because it ends in this ATE, we're going to change it to ick. Remember 8 ick? So phosphoric acid is going to be the correct name. Again, because it has that oxygen, we don't put hydro in the front. That's only if it doesn't contain oxygen. And we changed ick from 8 because that's what rule 2 says. Okay, HBr, does it contain an oxygen atom? No. So we're going to go straight into the name. It's going to be hydro. And Br stands for bromine. So bromic acid. Okay, so hydrobromic acid, because it doesn't contain an oxygen, we have hydro, we have ick, and then our ending acid name. Okay, HI, does it contain an oxygen atom? Nope, so we're just going to go straight into the name. Hydroiodic acid. Okay, hydroiodic acid. We would drop the INE for iodine and add the IC ick at the end. So again, hydro and then ick at the end, and then we're good to go. All right, the next one, HC2O3. Oh, I can't read. Okay, HC2H3O2. And we should recognize that H2. Oh my. We should recognize that C2H3O2 as the polyatomic ion for acetate. Because it does contain an oxygen, that name does matter. So acetate, you know it ends in ATE, so we're going to change the ending from H to ick. So we're going to have acetic acid. Okay? So that's what you're going to follow each time. The biggest thing is hydrogen taking the cation place? If it is, you know that you're going to need to name it as an acid. If that acid contains an anion with an oxygen, you need to look at your ate versus ite, and then determine whether it's ick or ous. If that anion does not contain an oxygen, you're adding hydro to the root word as a prefix and ick to that root word as a suffix. Okay? So now you are going to have a worksheet where you are going to practice some of these. If you have any questions, make sure to re-watch the video or send me an email. Okay? Good luck. We'll talk to you later.